learners, welcome to Trial. Today we will learn about object classes and typecasting. So what are these object classes? Object is the root class of all classes in Java. You know this. Now every class in Java is implicitly extends. Every class in Java implicitly extends from the java.lang.object. All the classes are all extended from this java.lang.object classes, which is the superclass of all objects. It's the superclass of all objects. Either directly or indirectly, we extend these classes. Now, the key features of object classes. Here the object classes will extend the toString method. This will return a string representation of every object that is provided. It will return a string representation of that. Now equals object O. It will compare two objects for equality. If they are equal or not, it will compare for the two objects comparativity. And now hash code. It will return hash code. This is used in hashing. Return hash code which is used in hashing. Now get class. It will return runtime class information. Get class will return the runtime class information of which this class belongs to which class. Now clone. It creates a copy that is shallow copy, not original copy. It's creating a shallow copy. This clone method will create a shallow copy, and this finalize method is called by garbage collector and before the object is destroyed. Once we destroy the object, they are obviously garbage collected, and this finalize method is called by garbage collection before the objects are destroyed. Yeah. Now using the object methods, how to use these object methods, we'll learn here. Suppose there is a class. There is a class person. Here there is a class person, and which has a field property as string name. Now there is another constructor person which has a field property as string name. Here the field property is string name, and here the parameter is string name. Here in constructor there is parameter string name. By this name, we will assign the name to the name which we provide here. By this name, we will provide by this name. This name is assigned by the name which is provided from here, from here. Yeah. So public string to string, it will convert all the things to string type, and so finally we will return the person name plus name, which we have provided the name that will be returned back here to the following classes. So coming on to here, we have public class test, which have the public static void main as main method line, string args, and here we are forming the object of person, which we are forming the object of person p equals new person, and we are providing the name as Sean. With the help of new, we are creating the object, and to this new we are providing the name as Sean. So on writing system.out.println p, we will get a toString. This method is automatically called, and all the things which we will provide, they will be converted to string type and will be presented as we have provided. Now system.out.println p.get class. It will refer us to the classes. This will refer to the runtime classes that is p, or that is of p type. This will refer to the classes that is being provided by the p object. P is the object, so it will refer to that. This object will refer to the classes that it is running. So coming further, we have the typecasting. There is casting in Java, and there are two typecasting which are called as primitive casting and reference casting. Primitive casting refers to the basic types as byte, short, int, long, float, double. These are the basic types from which other data types are created. They are the basic types from which other data types are created, and other objects or classes are created. Yeah. So here we have the int and float, which are the primitive type, and now reference type. Here it refers between objects, that is classes and interfaces. Reference refers to the classes that reference particularly it tells about which class, or it refers to the interfaces. And now primitive typecasting. Now coming to primitive typecasting, we have two types of casting, that is implicit, that is widening. Implicit casting, that is widening. Here, suppose there is a variable int of integer data type. It will obviously have less memory area, as will have contain only the integer part. And now let's there be a variable y. Y. This variable belongs to double type. Double, as we know that it occupies more memory. Apart from integer part, it will have decimal part extra added to it. So when we cast this integer data type into this double data type, means we are extending this integer memory into double memory, which will have longer memory. So this is called widening. Casting of the small data type into bigger data type, smaller memory data type into bigger memory data type. This is called widening. And explicit. This is called narrowing. An explicit destination that is not narrowing. Suppose there is a variable double data type having more memory, no more having more memory. This variable will have more memory and double. It is named by data type as double. Now cast this to integer data type. Suppose we are casting this variable a is having double type into integer type. This double type a is cast to this integer type, and finally stored the variable b. This will always reduce the memory of this because integer is having less memory, and when double is casted to integers, double is casted to integer, this double is casted to integer data type. So it will be shortening of memory and it will be storing only 10. Now remove this, there will be removal of this decimal part as 0.5 will be removed from there. Now reference typecasting. Upcasting. Suppose there is a upcasting that is converting the child class to its parent class. Uh, here here class animal. This is the animal class, and there is a class dog. There is a class named as dog. Yeah, dog, which will extend animal. So it will acquire all the properties of this animal class. It will extend animal, so it will acquire all the properties of this animal class. This dog will acquire all the properties of this animal class. Now when we cast this dog which is the base class, that's a child class, which we will cast this dog type into its parent type object, that is a. It is called upcasting. Casting of the dog type, casting of the base type into its parent type. Casting of the base type into its parent type is upcasting. And now downcasting, that is parent type to child class. For parent class to child class. Suppose there is dog D, and dog D is again there is dog D and dog A. And now when dog A, dog when A, that is of parent class. A belongs to the parent class. A is an object found by the parent class. This object A is now casted to dog. Is casted to dog. Now this parent A is casted to dog, and finally it will be stored in the dog D, object of the dog. Finally it will be stored in the child class object. So it is countdown casting. Casting of the child class, casting of the parent class, casting of the parent class to its child class, casting of this parent class to its child class, parent class to its child class, child class is called downcasting. So there will be runtime exception, class cast exception if A is not actually a dog. If there will be runtime exception if A is of not of dog type. Here A was of dog type because A is passing. A is because A here A is of dog type. Yeah. Now because we have created the A with the help of reference of dog. Yeah, we have created the object with the reference of dog. Now coming here, there will be a class exception if A is not actually a dog. If A is not actually of dog type, then there will be exception. There will be exception. Yeah. Here we are creating the object A with the help of dog, so A is also of type dog. Now coming to instances of dog, they are used to check object type during downcasting. They are used to check object type during downcasting to which object they belong. If A is instead of dog, if A is instead of dog, then then dog D we are then A which is being casted to dog type, and finally stored in the dog type D object. Finally A is casted to the dog, A is being casted to dog type, and finally being stored in the dog D, the object of dog. Yeah, D object of dog. So we can call all the methods of dog with the help of d dot bark. Now real world analogy. We have some similarity between the classes and real world. So for coming up in real world, we'll find that a dog is an animal which generalization, which is in general form, which we know that dog is an animal. Yeah, and this is upcasting. This is upcasting. A dog is an animal, is an upcasting, and because it has four legs. All animals have four legs, and this similar properties only we can show that dog is an animal. And now downcasting. Not every animal, but every animal is not a dog. This is downcasting. This is downcasting because every animal is not a dog. Now coming to sub common cases, polymorphism. Scenario that is polymorphism. There is polymorphism. Use here polymorphism also uses upcasting to hold child objects. Upcastings are always used by polymorphism to hold child objects. Now method parameters. It accepts superclass type for flexibility. For method parameters, it accepts superclass types for flexibility. The methods will accept the superclass type parameters for its various uh, for various castings and different purposes. Yeah, for example, collections. The users need to cast from objects. Here, the collections, which is pre-generates, they need to cast from objects. The collections, they always need there is always a need that they cast from objects. From objects, all the things are derived from objects only here in collections. True. Now, other examples of upcasting and downcasting. Suppose there is a class animal, which forms a method sound, which produces a method sound. Now there is a dog, which will extend animal class. So it will acquire all the properties of this animal class because it is extending animal class. Now, in spite of having a sound method called sound, it will inherit all the properties of animal. This dog, so it will have a sound. So it will also have this method sound because it is inheriting this class. And now apart from that, it can also form its own method like bark. Dog will also bark. This method belongs to this dog type also. Now this public class test is having a public static void main string args, that is the main method line, and the animal object of animal is found a with the help of new dog object with the reference of dog object. Now this is upcasting because we are using the subclass, that is dog, to form the object of animal class, that is the parent class. This is upcasting because we are using the animal, which is the base class, to form the object of superclass. So we can form the call the subjects all the objects of all the methods of superclass, that is sound, which lies in the animal class. So this can be called by this object. Now if a is instance of dog, if a is instance of dog, means method a is instance of dog, it is found by the help of dog. Then dog d, then we can cast this object. Then we need to cast then this dog a object, and we cast it to this dog object, and can be stored in this dog d object which we created here. A object is now casted to dog object and finally stored in this dog object formed of d. So this is downcasting. So it will also form the call this downcasted object can call the objects of this base class, that is dog dog, that is bark. Yeah. So there can be casting errors too. There can be casting errors as suppose we are forming an object A with the help of new keyword, and that object belongs to that animal keyword, and that is being formed with the help of animal class only. And now dog D cannot be casted to object. Now a object cannot be casted to the dog D object, cannot be casted because this object was found with the help of animal class. This dog is found with the help of animal class. If it would have been found with the help of dog class, then we can only cast them. But here it is a dog object A is found with the help of animal class, so it cannot be casted. You show class abstraction. Always use instead of to check before downcasting. We should always use instead of. It is required for us to use instead of because it will give us to which class it belongs. It's always required to use instead of to check before downcasting. Now, object versus casting summary. We have learned about the object classes, which is the base of all Java classes. Now, upcasting, it is automatic. Upcasting is automatic and safe because in upcasting, there is no loss of data, no loss of data. And downcasting, it is manual. It is found by the user and is risky and unchecked. It is risky and it is unchecked, as there is always loss of data here. Uh, and the instance of it is used to avoid runtime casting error. Instance of use in every class to avoid runtime casting error. As instance of checks to which class or object it belongs, then it is helpful in casting that variables to a particular method or object. So they are used to avoid runtime casting and errors. Now, thank you. We'll meet in the next class now. Thanks.